Hey everybody, my name is Yurii. I moved to Comox Valley about 2 years ago, so it's actually fun to finally actually come to this co-working space. I've never been here. It looks amazing. So anyway, so let's start here. It's a quick question just to make sure. Do we have anybody in the room who does not know what Postgres is? Good. At least a few people. So Postgres is the world's most advanced open source relational database, as they claim. Basically, the numbers that I saw for last year, they're probably 16% of the database market, where 16%, and it's out. No, well, maybe. Yeah, it is. So somebody has to keep pressing the function button. No, I think well, power cord will help. Yeah, yeah. If somebody has the max save. No, max save.
Go to sleep.
Yeah, wherever that is. They keep changing the locations of that. Yeah.
I know.
Yeah, you can just press the button or something.
I can just hang out here and draw on the screen.
Yeah.
That sounds great.
Anyway, so it is, as they claim, most advanced open source relational database, and according to some researchers, it's about 16% of database market overall, which is not a small number considering there's Oracle, Microsoft SQL, and God knows what, and Amazon offers just about everything as well. So a lot of projects are being developed with Postgres for the past 20, 30 years, but especially in the last 5 years or so, it's been a recent sort of uptick of use, and I think it's partially Oracle to blame when they bought MySQL. MySQL users are like, well, we use MySQL because it's not Oracle. Now it's Oracle, so goodbye. So that's how Postgres also continued to grow. So I'll tell you a little bit of story, what it's all about, like that I'm going to talk about today. I've been a software engineer pretty much my whole life and an entrepreneur as well for the past 15 years or so. And that means I've started programming late 80s, I think, somewhere there. And over time, I've noticed how many inefficiencies we have in our software development process and our actual software, how fast computers are today and how slow our software still is. It's basically trying to compensate the advancements in hardware, by kind of slowing itself down. So that bothered me for many, many years, and I've tried to figure out what to do with this. And in the fall of 2022, I had just a fun sort of geeky idea. And I have a tweet to prove that. So I was actually consulting a company back then. You may know this company if you're using Postgres. They're called Supabase. And I've been advising them basically on how to build extensions. Some of my work saw the light of the day with them. Some has not for various reasons. Huh? I know a bunch of people. Anyway, so that was my post, and the idea, hey, after I finish, after I'm done doing whatever I was doing, I'm just gonna build a complete application development platform just right in Postgres, because it just sounds like fun. You can deploy to it, you can serve, your web endpoints from it, you can design APIs, run, your business logic basically, and people were saying, things like it's the OG of, Kubernetes type of thing. And that person actually was one of the early members of Heroku. He lives in Vancouver. So I was thinking that's kind of cool. So it took me 2 months to finish whatever I was working on, that I was mentioning in that tweet. And I came back to this problem. And so in December 2022, I basically set off on an adventure. Let me pull this up. Oh, that's the wrong one. Command back. Yeah. And forward. Too many things. So basically the idea was, can I actually put an HTTP server inside of Postgres? and what will happen if I do that. And I took one of the HTTP servers. I think it's actually currently used by Fastly, if you know this CDN, so one of the sort of smaller competitors to Cloudflare, and they use it to serve HTTP 1, HTTP 2, HTTP 3 traffic, at a significant scale. And so I decided to just try, like, what if I put it inside of Postgres, and basically whenever HTTP request comes in to your server, it immediately gets served by, well, something as simple as SQL query. Because oftentimes, especially when we build APIs, all we do is pull the data from the database and make a JSON out of it. Goodbye. And backends, when they sit between the database and the user, all they do, they translate this HTTP request into a SQL query, wait for the results come back, and translate them back into JSON, and life goes on. And basically, it's just like, remember that movie, The Office, when the person was asked, what do they do? Well, they bring requirements from the customer to the developers, and and that's their job. So backend oftentimes ends up doing that. They take the request from the users and translate that to the database, pull the data back, and send it back to the users.
Yep.
That like saying most of what Costco does is it gives me stuff, and so that she just give me stuff faster?
In a sense, yeah, just give me faster. But anyway, so at first, I mean, implemented it. It was a fun thing to do. It was really difficult because Postgres was not agreeing with a lot of ideas that I had there, but eventually had to comply. But what was interesting, finding that where's my mouse here? Here. Here's an example of how, at that time, I was writing handlers for HTTP. You can see those part kind of in the middle where I'm immediately returning a response, for a response, and a response, I think, with some JSON inside of it, whatever. So when you run it, it looked like a regular, HTTP request response type of thing. So that was fun. It worked. But what was interesting, actually, it was numbers. So I implemented the same hello world type of service that basically takes your username from URL, goes to the database, fetches your real name, and says, well, whatever your name is, hi, John. And I implemented it in Node.js, in Rust, and in Omnigres, basically in, well, what would become Omnigres at some point. And Node.js did about 20,000 requests a second, maybe 25 sometimes, and that's on this computer. So it's Apple's M1. That was not a bad number. I mean, it's not a bad number at all. Rust was doing 30 to 40,000, allegedly. The HTTP server is faster, compiled code and optimized and whatever. But then Omnigres at that point was doing 124,000 requests a second, just because there is no inefficiency between them. Basically, there is no translation, there is no network, there is no serialization data, there's no additional memory allocation, nothing. Just nothing stands in the way between the user and the data, because users care about the data, whether getting it, updating it, whatever. So that's basically the experiment that started this whole thing. Any questions so far, just to make sure the pace is right and I'm not overlooking any details? Good. Let's see what's here. Yeah, basically just showing some numbers here, and this was actual JavaScript code that was doing this. Yeah, basically that's it. And here's actually an example that I just wrote while listening for the doc presentation. This is just a query that effectively returns city names, population, and when the census was roughly taken, because I don't know the actual dates, but sometime in 2016. And the way this handler looks right now, the useful line is actually just line 14 there. Like the rest is just stuff that should eventually go away. It's just a setup. So it just selects the response from an aggregate over cities. That's it. And just spits it out. So it's pretty simple stuff. So if we add cities, to that insert, wherever my mouse is, see, it's just 2 cities there. that's basically the entire sort of API endpoint here.
So it looks like you've got like a extension to SQL, like a DSL that kind of turns a SQL query into an HTTP handler?
Well, basically, it's actually SQL still handling it. So basically, what the extension does, it brings the HTTP server inside of Postgres. So it basically lives in the same address space. So there's no essentially data copying, right? So when we receive the request, we read it out, fire off a query, get the results, get the data out of the, say, JSON, right, and just send it off. That's it.
So if I wanted to add like some procedural code or some business logic, can I do that, or you would do that outside of the?
Oh, yeah, you can. And actually, I think I should have made one more tab there, but I can add that if there's interest. So you don't have to write it, say, in SQL. SQL is just when you say experiment, and if it's really trivial, like it's literally just the JSON out of this table. That's all it is. It's super efficient way to do this because you would have made this query anyway, right? But you can write things, for example, in Python. So you can even literally bring like Flask, the Flask framework, and run it inside of Postgres. So we have OmniPython, which allows you to do precisely that. So basically, you take your normal Flask code that takes WSGI HTTP requests. That is the standard for Python, and you talk to your database. Do all the things. You use Python as much as you like, but it's still running inside of the database. It's still faster. I think somebody from our community have been measuring this, even without touching the database. Just having our HTTP server made it faster. Just not using the Python, Python standard web server, just because stuff that we run is really, fast. It's just it's implemented in pure C and and optimized for CDN use cases. So it's pretty good at that. And actually, the entire platform is implemented in C too, which is a fun discussion, that can be also had. Anyway, that was just a quick demo of how that looks like. And so after that, I wanted to gauge, do people care about this? Can people even use this? So I set up this mini contest. And the idea was simple. I would give them a couple of challenges over a very simple project. Like, this is what you get as sort of starting point. Very simple service that has message of the day table, a couple of functions that show message of the day, allow you to update it, and I just issued a few challenges. Can you do this? And the idea was basically to get people interested and come to our Discord channel so I can basically meet them. And I attach some cash prizes to every challenge. The problem, however, if you look at the comment section where I asked them to submit the solutions, they solved it within a week without ever coming to Discord channel. So I had to pay the money, and I met just this few people, few dudes, I think 2 or 3 of them. But what I was surprised about is they were able to solve these challenges with no sort of education on my end, with whatever documentation that was available at that time, and that was kind of easy for them to do because they quickly iterated and solved all the challenges. So to me, that showed that there's promise in a sense that it is a simple enough model for people to understand. And that has led to proliferation of whatever other things that we've built. So there's a tool for working, with S3, right, within your Postgres. So you can, for example, upload files to S3, download them, do whatever you want. HTTP client, obviously HTTP server, JSON sort of mapping between tables and your data types, so you can easily define how you want to map your tables to JSON. Tons of tools for like MIME types and integration with operating system. The Python stuff that I was just mentioning. So you can, here is an example, you can write just regular Python code and expose it to the database, or you can write where it would be your Flask application. So right here, you can see it's a regular application in Python and using Flask, and a bunch of other things. So as you can tell, there's probably about 15 of them right now. But the problem was, how do we get this sort of really used, and how do we get people hooked on whatever ideas we have? So mid last year, me and my co-founder, we decided to create a company out of this and basically create a full-time effort around this whole project, around the idea that we can solve inefficiencies in software by collocating data and code and looking at all other aspects of what makes software inefficient today, both sort of socially and technologically. How do we reduce the surface that we have to touch when we develop software? And for me in particular, what was important is actually sort of distanciating ourselves from what cloud does these days. As you might have noticed, a lot of people have become, say, cloud architects. And they do useful jobs, but partly their job is to sell Amazon to the team, right? Because like, well, buy this service and buy this service, right? And it's really great for Amazon's business. I mean, like, they've done an amazing job basically creating jobs that create revenue for them. But in reality, most of projects and most of companies don't really need that level of complexity, that level of expense. And we figured, looking at how the economy is playing out now, and by observing what's happening on the market, there is a pool for faster, cheaper solutions that have smaller hardware footprint, require less developers, and you can ship faster. Basically, reduction of bad things and increase in good things. Simple things, really. So we ran with this idea. We raised a pre-seed round, still having no clear idea how exactly we're going to sell this. So we talked to a bunch of potential customers. We signed up one. There's a company in the US that are developing private equity, secondary equity sort of market, both trading engine and auction. Hopefully it'll come back. Yeah, it'll come back, and they're actually using it on a bunch of these extensions. So HTTP server, S3, whatever. Like they're using a good portion of these, but it was still unclear, as I said, like how exactly do we get into this market at scale, and sort of what's our wedge? And we kept talking to people and kept observing what efficiency means to people. And after a lot of interesting conversations with our existing investors, it kind of came into us. So we have to focus on really fundamental problems. And one fundamental problem is obviously, always performance, because it leads to explosion in cost for hardware, developers. Basically, everybody's trying to solve these performance problems. And we realized that the problem of slow queries is not really solved yet. Basically, if you think about it, oftentimes when our applications talk to the database, the amount of work that the database has to do is quite big. And oftentimes what happens is the queries that they make oftentimes are repetitive in their nature, as in the data hasn't changed. The computations return the same results over the same data sets, and yet we keep rerunning this on the same data set all the time. So we're wasting cycles repeating ourselves. And so the idea became pretty simple. Hey, how about we actually provide a good cache for Postgres, so that when they send a query, they get a result faster. As simple as that. And the interesting outcome of that experiment was that we realized, based on our knowledge of Postgres, that unlike other solutions, basically, if you just look at the query itself and cache it, the only thing you can provide to a customer is basically a cached result of that query. If they send a slightly different query, well, we got to read it out, recompute everything. It's kind of not really interesting. But if you know about how databases work, in particular Postgres, basically when you send a query to Postgres comes up with a program, query plan, basically how to execute this query. Because the query itself tells you what I want out of the database. But the query plan basically says, that's how we're going to do this. We'll scan the table, we'll scan the index, we'll apply these filters, we'll sort things, aggregate things. That's what it's doing. And so Omnicache, basically what it does, it caches intermediary results of every step of that way, which means if you have two queries that are not the same, but they use same portions of the algorithm how to fetch the data, they both benefit from that cache, because that cache is getting reused. So I'll actually show you a short, wherever my mouse cursor is, here, a short demo that my co-founder recorded just today. So, I mean, it would be amazing to hear any feedback about it, because we just started sending it off to people who are interested. And it's short, so that should help. I think it's sending audio somewhere else, right?
Probably to the projector.
Yeah, I'll try to send it to my. Can I hold this? This thing is not being moved. All right. Can you see where is the? I cannot see where is the audio. No, Cliff.
Is it the one that says
To the
muted?
left.
Huh?
To the left by the little computer screen? Is it the one to the right of it? Keep going left?
First quarter of the black.
Another 3 inches, 6 inches.
There's way too many of them.
2 more. That one. Is it that one?
No, that's Docker.
Can you choose it just left of the Siri icon? Does that not give you options there? No, it's just left of that
Yeah.
one. And then go down to the
Sound.
sound.
It's muted. There you go.
And then if you click on the arrow there, it might give you options of where the sound's going.
Yeah, that also. Yeah, built-in liquid retina.
No,
So that's displayed.
Yeah, display.
Go back to the icon left of Siri. Yeah.
Put everything there.
And then on sound, there's an arrow.
Now playing California. There's no end to love.
Okay.
It's still playing on MacBook, so I think that should.
Term of Omnicache. If you are frustrated with your SQL queries being too slow, this might be of interest to you.
Put the microphone.
Add 2 instances
I think I pressed the button.
of Postgres running on my local machine. One on the left where Omnicache is installed, and then one on the right there is no Omnicache. And I prepared a simple table called Nifty. Let me run the same command against the instance where Omnicache is installed. Nifty is, by the way, the equivalent of Sensex from Indian Stock Exchange. Let's run some queries.
So here it's just counting, the numbers.
It's taking 17 milliseconds or 10 milliseconds with Omnicache, and without Omnicache, it's taking close to 500 milliseconds. All right, let's run some more complex queries. I'm finding the minimum, maximum, and average of all the symbols within the Nifty table and ordering them by ascending. Running the same query again here. 23 milliseconds and 3500 milliseconds. Let's rerun. 14 milliseconds. 3500 milliseconds once again. Let's run a different query. Instead of doing order by ascending, let's do one by descending. milliseconds and 3400 milliseconds. Same query, I'm rerunning. 15 milliseconds and 3970 milliseconds. Yeah, that's the power of Omnicache. It's a Postgres extension that can be installed natively within Postgres. Please give it a try. Thank you.
Thanks. I think it's back on now. But this is out. But anyway, that was sort of a last slide. There's a little bit of an executive summary on the next one, which we can quickly glance at.
Yurii, is it tied in enough to the back end to know when to invalidate the cache, or is there a risk of stale reads?
So basically, we have two core principles here. One core principle: never serve stale data unless instructed to do so. So we're actually spending a lot of time coming up with rules that are basically we we don't cache anything by default. So we have rules that qualify queries for caching. So we say, in a case, if all these rules apply, and then we can say that this query is eligible for cache. Otherwise, if we're hitting something that is not part of this rule set, it does not qualify for caching. So that's kind of our first level of protection. Basically, don't cache stuff that is not supposed to be cached. Like, for example, you're using functions that are not guaranteed to return stable values for the same data sets. They are randomized or whatever. They're doing whatever stuff. And the second one is because it's integrated into Postgres. So it's observing every query that goes through Postgres, every transaction. Basically, it invalidates based on those observations. And this is actually quite interesting because it has features that are kind of impossible in the model that has been used before. Like pgpool has caching functionality for Postgres, or there are like commercial vendors like Redis. But basically, with them, they sit as a proxy in front of the database. So basically, all they can do is sort of look in their cache, say, if there is a query that we already saw, and we'll serve a cache. But on our end, we work, for example, transactionally. So for example, you start a transaction, you change your data, the cache is local to the transaction. If you roll it back, nothing happened. And it's not seen outside of that transaction in other connections. Then other things, if you're aware, like Postgres has a role-level security model. So basically, you can tell under which roles, under which conditions users will see particular rows and tables. None of the solutions can do that because they're outside of Postgres. But the way we see the queries arriving to us, it allows us to say exactly what that query is, what it's looking at. So we'll actually cache according to your role and permissions of that user, and that will not be shared with anybody else. And it requires very minimal footprint because it basically, again, there's no extra server that you have to put. It's still the same connection string that you have to use to connect to that database because it's still the very same database. And what also is great about it, let's see what I forgot, because I have not slept for a long time today. I know there's something. Oh yes, there's another important part with the model where we have this extension built into Postgres. It's the one on the bottom right. Basically, it's both the external clients and the local clients, such as stored procedures, that are getting the boost. The problem with the proxy in front of Postgres is that your stored procedures will never benefit from that. And why do people write stored procedures generally? That's because they want speed. It's faster. And then so basically if they don't, these procedures no longer benefit from additional boost, what's the point then? Like, we kind of, it's kind of regressive. But this approach, for us, it doesn't really matter where the query comes from. It could be even from an extension written, for all it matters in C, that just sends a SQL query. We don't care. It's the same query. So that's pretty much it, for Omnicache. So basically what we're seeing on the sort of adoption side, we've started talking to a bunch of bigger companies, because obviously it's bigger companies that typically face these challenges when they have tens of servers, really big boxes. They're basically maxing them out as much as they can. They have tons of replicas, like 10 read replicas per server. And this is too much for them. I mean, it fails more often. It costs a lot more. It basically costs a lot more in servicing. So when they hear this, about this model, they're like, okay, how can I measure, the efficiency of this? Like when is this going to be released, etc. So this kind of question. So we're seeing definite sort of pull from the market. They're saying we want this because nothing like this exists on the market right now. And that's pretty much it, I think. So I'll take questions.